I can't talk over you, so you don't have to take extra speaks today. Or a pair of polar coordinates.
Oh, wait.
How do we do?
Hold on. You draw the triangle.
Okay. Well, you get a square tube bill. It could be positive, it could be negative, it depends on what angle you choose to use. Does everyone agree with that? Say we choose positive out of negative 45 degrees, negative 5 degrees. So make sure you're reading directions. There were some problems last night that said equations. Don't know what I'm talking about. Just make sure you're reading directions. If you didn't read directions, come back and read them. Any questions about that one? So far? That's one. What did you say? You sure?
Yeah.
What else?
Negative.
Good, so we do 35 or 4. Go to the positive, instead of negative 5 or 4, do 7, 5 or 4. Good. You got a lot of options. What other way was important?
Negative 2. 11.
Where'd you get the 11?
At 5.
We just went all the way around the circle again. We can do this all day long. Today we're going to learn how to graph polar coordinates by hand and in the calculator. It is going to be slightly tedious, but also somewhat fun because it makes some cool pictures. So. Okay. Even though I want you to be able to do this completely by hand as far as the values, there are going to be times we pull in some decimals, so I have a calculator handy to do that. My R is 1 plus cosine of theta. So I'm going to take several theta values and go find a radius at those theta values. So what's the cosine of 0? What's 1 plus 1?
2.
What's the cosine of 30? You just subtract it. Square root of 3 over 2. Square root of 3 over 2 plus 1. Someone tell me the decimal value of that. Normally I do 3. On this, since I'm going to plot it, I'm probably not going to be better than a 10 on my plotting. So. Good. That one I could do completely by hand, right? Because 1/2, 1 plus a half is 1 1/2.
1.
Good. That one. Cosine of 0 is 90. Cosine of 90.
0.29.
Everyone see how I'm getting these. I'm going to go ahead and now practice your unit circle in case you ever did in Cal 2 have to do any of these completely by hand. ones that you could do and work with it. But for the rest, we're just going to speed things up. Okay, here we go for 150.
Oh, sorry, 1 point. Yeah, that's right.
180 is 0. 210 decimal. 240 is not a decimal. It's 1/2. 270 is 1. 300 is 1. 1.5. 330 is a decimal. So in one full cycle, I'm going to go plot those points now. So, how do I plot those points in polar coordinates? Right, I'm going to start at the beginning and work my way around because it doesn't matter what order we write these down in. So, 0, 2. Where's that? 0 degrees, 2 minutes out. Okay. 30, 1.9. So a 30-degree angle, 1.9. 45, 1.7. What am I going to do in between those two lines there? 130, 160, so 45 somewhere in between. 60 is at 1.5. 90. 1. 120. 135 is at 0.29. 150 is at 0.1. Been kind of tough to graph, but keep plotting. 180 is at 0. Is at 1. 40 is at a half. 70 is at 1. Am I going too fast? Are we okay? We'll talk about that calculator. 300 is 1.5. This is actually, if you look it up in the textbook, called a cardioid. So any of them had some biology would know why it's called a cardioid. It looks like a heart. If you will, get your calculator out. We put our calculators in polar coordinates yesterday. Go to the y equals, which is now r equals, and type 1 plus cosine theta. Mode. And you see where it says function. Go over to polar. No else. Okay. Okay. I'll let me get into the words. The rest of it's be all be on r. Okay. It won't stick here.
Give me here.
Okay. Go. Whoa. Hold on. Before you give up on your calculators, have you thought about your window or your mode?
Yeah.
Maybe. Right. First of all, what is your degree? Are you in degrees or calculator. Don't answer out loud, but think about it. Go to your window. Everyone go to window. Before you go to window, make sure you know whether you're in degrees or radians, because that's really important. Why? When you set your window, you're going to set a theta value. Well, if your theta is from 0 to 2 pi, but your calculator is in degrees, how many degrees is your calculator going to plot? About 6 degrees. Not going to go very far, right? So we need to make sure that our calculator matches up with what we're trying to do. So go to your window. Theta min, if you're in degrees, what would be a good theta min? 0. And what would be a good theta max if we're in degrees? 360. What about in radians? 0 to 2 pi. So it doesn't matter which one, just make sure. The theta step is how often, just like the x step in your Cartesian coordinates, is how often your calculator plots a point. If you're in degrees, and you do like 0.1, it'll be a beautiful picture, but it'll take a really long time for it to graph. Why? Yeah. Because it's plotting a point every 1/10 of a degree all the way to 360. So it takes your calculator a long time to do. If you're in radians and you're 0.1, that's probably a good thing, because what if you did 1 for radians? You're going to plot 3 points. It's going to be a horrible graph. So that's what the theta step is. So if you're in degrees, something like 1 would be a good choice. Plotting a point every 1 degree is probably good.
I can't even hit anything because it's so rough.
Push the on button. It will always break whatever your calculator is doing, and you can go change it.
That's a lot faster.
What's it say? Go back. We're not done with our window. Go to your window. Okay, go down to your x min, x max, y min, y max. Those are the same as always. They're just telling us how far out left and right and up and down your screen is going to be. So negative, 2 is the biggest we got. So maybe -5 to 5, -5 to 5. You can do whatever you want, but that's what those do. What you want? Oh, you're invalid.
Big Pac-Man. It's really wide.
Hey, question. I do want on your homework tonight, everyone listen, on your homework tonight I want you to point plot. I don't want just a calculator sketch, because I just want to make sure that you understand how they're working point plotting wise. However, can you check in your calculator?
Yes.
Please do. Let's do one more with point plotting. I want you to try. Yep. I didn't give you points. So which ones would you pick? Probably the same ones, the ones on your unit circle. If you need to get more specific, we'll do that later, but I'd probably pick some points on the unit circle. So try this one.
What are we doing? We're graphing.
Okay, you're in degrees, right?
Oh.
It looks really.
This is such a tiny step, it's going to take it forever. You're going to put your thing step at 1. Now, if you're in radians, that's a bad choice. Okay, your y min is right.
Work together.
I'm gonna change them.
So what your calculator was doing is way under. So you can see.
Thank you.
Okay, go.
We're trying.
Okay, go away to table. Thank you. So plug in 0, plug in. Well, you'll do 0. If 0, 30 does it all the way. We'll do a bunch. However many you need to get a picture. Now, we're new at this one, so we probably need a lot to get a good picture. Later we might try to be a lot consistent and go here and there.
35 good.
I want to see my hand. But yes, that's what it's going to look like. Isn't it fun? I take three pictures. Now you can use your calculator.
Yeah. And times that that's 2. So it's a bit. If you
Zero in, okay. What's cosine zero?
1. What about this?
Okay, what's 2 times? So what's the cosine of 0? So I did that, you're right. Wait, no. What's the cosine of 60? And now you see why I said 60. Cosine of 60. Good. Let's look at 2 unit circle practice.
Distance is 0. Negative. So that's going to be negative. Alright, good.
Isn't that 3?
Negative 1. So it's going to be negative 3.
I got this out of the textbook. They did way too much work. You can do a lot of that in your head, but that's okay. You can see that they're doing it kind of step by step, and that's beautiful work. Students like you probably would not want to write all of that down. You would probably want to do that in your head, but you can do whatever you want. Are we getting some values kind of like that? Now, you probably just did 0, 30, 60, because that's what we did earlier. What allows us to do 15? And when you double it, it's still a unit circle value. On this type of curve, the rose type curves, the more petals you have, we'll find out how to know that in a minute, the smaller you would want to do your steps when you're doing it by hand, because you're going to have more pieces involved in your answer. So anyway, point plot, 0, 3, 15, 2.6, and again, you probably don't have that one, that's okay. 30, I expect that you do have that one, just 1.5. 45, 0.
Is it 1.5?
It is, thanks. Very much farther down. 45 is 0. 60 is negative 1.5. How in the world do I put negative 1.5? Okay, good. So over here, I go this way, right? The negative radius goes to the other side of the pole.
It's really hard to do.
Sorry. Which one?
Oh no, like paper with all the circles.
Oh, is it hard to tell? The grids tonight are pretty good. They're nice grids. 75. Again, you probably didn't do 75. That's okay. So it's this angle here. Negative 2.6. And negative 90 degrees is negative 3, which would put it down here. Agree? 105, which is this angle here. Negative 2.6. Put that down. And then 120, negative 1.5. You can kind of draw as you go. Right, so we've gone here and looped around to here, right? Everyone see that? The loop, we've gone this way and looped around to here. What are we on? 135? No, we already did 135. 150 is 1.5. Go back out on the other side. 165 is 2.6. 180 is negative, or is 3. I think I have more tables. No, maybe not. Did we get 3 for 180? I've lost the rest of my table, so you're going to have to answer the rest of them for me. What is, what's this angle, first of all? Next angle. 210, and what's the value at 210? 1.5. So I'll get another pedal. What's the value at 225? 0. Okay, what is the value at 240? Negative 1.5. What does that do to it if we're negative 1.5? Goes back up, right? Coming up this way now. What about 270? Negative 3. Could you probably finish the picture at this point?
I don't know.
300. Negative 1.5. And then 3. 0, good. 315 is 0. What about 330? 1.5. And then 360 is 3. So we got a rose curve. So that was kind of fun. I'm going to go ahead and plot this one. I'm going to give you the coordinates, though, to save us some time. I think we could do that. Now, the one thing you would have to do on this one is r squared equals cosine to theta. What are you going to get when you plug in a theta for r? If I want r by itself, what do I have to do? Square root, and what happens when I square root? What do I have to do? Plus or minus. So I actually will get 2 r values for every theta value. Does everyone agree with that? So if I plug in 0, I get positive and negative 1. If I plug in 30 degrees, I get positive and negative 0.7. If I plug in 45, I get 0. Now, you'll notice there is a big gap from 45 to 135. So I'm going to try to plug in 90. Or something in between.
Just imagine.
Why? Square root of -1. So is that going to show up on the graph? So it looks like they've been clever. They probably tried. They probably tried 90. They probably tried all the way up till 135 when they were successful again. Because cosine of double the angle would need to be a positive value for zeros. What's the cosine of 135? Well, 2 times 135 is 0. So 135 is here. 150. I get plus or minus 0.7 again. And 180, I get plus or minus 1 again, and then you're going to get a repeating pattern on what you can do. So it's like an infinity symbol. It's called a limnescape. I could be saying that incorrectly. I have looked up the pronunciation several times, and I still struggle with it.
It's French.
Yeah. Okay, so these are some common graph types. For right now, you don't have to memorize them. I would like you to be aware of them. I don't want you to sit and write them all down right now because that would be a waste of our valuable class time. But I do want you to write down page 400. On page 400, you will see these pictures, the equations that go with them, and the graphs that go with them. So the first set in the book, they call it circles and limnescapes. You got circles, a cosine theta, a sine theta that makes a circle. Of course, arc is a number is also a circle, so that at the origin, we found that out yesterday. Limnescapes, we've got the horizontal ones and then the diagonal limnescapes. Limastones. And then limastones are parts of limastones are also called cardioids. I think your textbook broke it up and this picture didn't. Again, find those on page 400. Rose curves, and something fun about rose curves. If the so a sine of theta, if n is even, you get double the amount of petals. So we graphed, was it cosine of 2 theta earlier? And so we got 4 petals. So if you did 4 theta, you get 8 petals, and so forth. But if n is odd, you only get the number of petals that n is. So that's pretty interesting. Again, fun pictures to draw. Last thing for the day. In Cal 2 or in Cal BC, there's a skill that we're going to do where you're going to need to find the intersections of polar curves. It's very similar to finding intersections of regular curves, but it's something you need to be able to do by hand. How do you find intersections of regular curves? Set them equal to each other or do substitution. Does everyone agree with that? So I want to do that. I want to find the intersections between 0 and 2 pi when r equals 4 intersects 4 plus sine of theta. So how would I do that? Subtract 4 from both sides. And when does sine of theta equal 0?
That's 490.
Okay, 0 and at 2 pi. What am I going to answer? 0, pi 0.
Yes.
Theta is 0. If I'm finding an intersection in Cartesian coordinates and xy coordinates, what do I normally want besides just x? I also want the y value. So what's the y value in polar coordinates? The r, what is r? This one's almost too easy. It's 4. It R equals 4. But how would you find that if it works so easy? Plug it into either of the two equations. So R theta is 4, 0. Any questions about that one?
What if not pi?
Sine of pi. Oh yeah, we need pi, don't we? Yeah. Oh, good question. Why is it? It is pi. And 4 pi. Everyone agree with her.